Hello. Dear friends, exceptionally today I will start with the conclusion and only then will I proceed with the development. So, to conclude this talk, I have implemented a large-scale TeX Font Metrics format in Common Lisp, and this system is currently running on the whole TeX Live distribution. It checks for all the TFM files that are present in the distribution locally. And it also generates a website which we've set up with the help of Norbert Praining very recently. So the URL is here. It's updated daily and it currently spots a little bit less than 800 fonts with non-compliance issues with respect to the TFM format. Thank you very much. I will take questions now. No, just kidding. I have a little more to say about this project. So this project is actually a side project which I originally never intended to do. It's very young. It's less than one year old. And it's actually a side project for the ETAP project, which I was talking about last year, for those of you who were here. It's my experimental typesetting algorithms platform written in Lisp, and for which I needed, one of the very first things that I needed was to bring the TeX Font Metrics information to the Lisp language. So I wrote a parser for this font format, which is very creatively called TFM. And so this is the library. It's a quite simple library. The interface basically boils down to a single entry point, which is a very creatively named function as well. It's called load font, and it loads a font, and it creates so it loads a font from a TFM file somewhere on your hard drive, and it creates an abstract data structure in Lisp, which brings all the TFM information to the system. So basically, that's all there is to it. But the design of this library, for me, it's very. When I write a parser for any kind of format, I always try to be both robust and flexible. Robustness is something quite obvious when you write a parser. Flexibility is because I'm a sociopath, I'm a psychopath. It's a disease, but as we will see pretty soon, it also has some advantages. So what does it mean to be both robust and flexible when you write a parser? Because mind you, TFM is a binary format, but you're still writing a parser for it, even though it's binary. So for me, robustness basically means anticipate all the potential problems that could occur when you parse a file, binary or textual, doesn't matter. And be robust means that if you catch all the potential problems, then you can hopefully avoid crashing and or behaving, which is worse, behaving erratically. And so you can do something like, for instance, exit or give up gracefully rather than doing all kinds of nonsense. During the development of the TFM library, I identified 20 potential problems with respect to the parsing of the TFM format. These are, I insist on this is very important. I mean by that potential problems that are detectable when you parse the file. So for instance, incoherence or contradictory information that you parse, stuff like that. If the font is nonsensical in a way that you cannot detect, for instance, some character codes are missing, whereas they should be in there. There is no way that you can detect that. Okay, so there are a priori 20 different detectable non-compliance issues, and those issues come at various degrees of severity. Here are three very quick examples of this. Something which is extremely severe. So this is going to be an error, and probably a non-recoverable error, is a truncated file, for instance. Okay, so if a file is shorter than the declared size, there is probably nothing much you can do about this font. It's not going to work at all, and that should be an error. Okay. Another kind of non-recoverable error would be invalid section pointer. So the TFM format has lots of tables in it, and pointers and indexes into the tables. So if you have an invalid pointer to a section, it means that you've completely lost access to extremely important information. So there is not much you can do about this, okay, apart from exiting gracefully or giving up. Slightly less problematic, for instance, could be a problem in a ligature program. In the TFM format, ligature and kerning information is represented in some kind of very small and very simple programming languages, and it could be possible in a corrupted file that you end up with a cycle in a ligature program, which means that you would go in an infinite loop when using the ligature. Okay, so this is slightly less problematic in the sense that if you're able to detect that, you can just give up on the ligature program itself in the hope that the rest of the file still makes sense. Finally, there are some non-compliance issues which are not problematic at all. For instance, there are a number of strings in the header of a TFM file which are purely informational. So they are not used by the font itself. It's just there to give information to the reader, and that's all. So if you detect some inconsistencies in those parts of the file which are not used by the font itself, you can, for instance, just discard the information. It's not going to be a problem. Okay, so these typically should be only warnings. One final thing on the robustness matter. The interesting thing is that at places, the severity of a problem can be dependent on the context in which you are, or the time or the precise context in which you're parsing the file. A typical example of this is the design size in the font. So in TFM there is a number which corresponds to the design size of the font. There is a specification on it. It cannot be anything. It must be greater than 1, for instance. So if you parse a TFM file and you find a design size which is less than 1, that should be a warning or an error. So normally the font is not going to be functional because you cannot make any sense of the metrics, of the character metrics. Okay? The design size is important. But on the other hand, it is possible to override the design size. This is what happens when you load a font and you say font blah 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 at a design size, a precise design size. In that case, you have the possibility to override the design size. So suppose that you've parsed a font with an invalid design size, but you are overriding the design size with a value which is valid. Then in that case, the fact that the original design size is wrong is not so much of a problem as before, because you're not going to use it. So in that particular situation, for instance, the TFM library will issue a warning if the design size is overridden by the user with a correct value, but otherwise it will trigger an error. Okay? So that's it for robustness. Now, flexibility, we come to the disease part. To me, flexibility when you write a parser is the idea of providing as many recovery options when you encounter a problem as possible, rather than just giving up. Okay? So you see why it's an arguable feature of a parser. Most of the time when you load a font and there is a problem inside, what you want to do is fall back to another font and just say, no, there is a problem in there, I don't want to do anything with it. But because I'm a complete psychopath, I like to add as many recovery options as possible. This is arguable, but again, as we will see, it has some advantages, especially when you want to write not only a parser, but a validator. A couple of examples of these. I've currently implemented a dozen or so recovery options in the library. Typical examples of recovery options that you could get would be, for instance, as I was mentioning before, discarding bogus ligature or kerning program rather than just giving up, in the hope that the rest of the font is going to be functional, maybe at the expense of a ligature not being present in the output anymore. But if you can still keep on using the file, maybe that's something that you would like to do. Another possible recovery option is fixing the first entries in the table. So in the TFM file, the widths, 8s, defs, and the italic corrections table must start with the first entry of 0. It's, for the widths table, a way of representing a character which is absent from the font. So if you fall on a TFM file for which the first entry of these tables is not 0, probably the file is corrupted, but still in the TFM library, there is an option to correct the entry and set it to 0. Is this really going to work? You don't know until you experiment, but the recovery option is there anyway. Something very important to understand here is that recovery is black magic. Okay. For instance, getting back to the original point I was making, if a file is trunk, if there is an incoherency between the declared file size and the actual file size, for instance, if you find a TFM file which is shorter than the declared size, you can make the assumption that the file is truncated, but it could be that the declared file size is wrong and the physical file size is correct, but there is no way to tell. Okay? So you need to make assumptions, the most likely ones, and the ones typically hoping for the best. Okay? So this is really black magic, but it can still be useful. One particular area of usefulness of this is when you use the library in interactive mode rather than in a standalone application. Let me give you just an example of this. You might know that Lisp is it's a dynamic language, and you can either use it interactively in a REPL, or you can also dump standalone executables. So this is an example in which I've intentionally corrupted the CMR10 file. So here, normally the string which is here is supposed to read text. I've replaced the 2 letters with parentheses because this is supposed to be a BCPL string, and it's forbidden to use parentheses in those strings. Okay. So if you call the function load font interactively on this file, you will end up with that error. The BCPL string is invalid, and there you can see all the recovery options that are available to you. The obvious one is just give up, but you have also the possibility to keep the string as is, knowing that it's purely informative, so it's not going to be used anywhere, so you can just leave it like that. There is a possibility to fix automatically the string by removing the illegal characters and also replacing non-ASCII ones with question marks. There is finally an option to just remove the string from the final data structure, just pretend the string was not here in the first place. And something which I have not represented here is also the ability to interactively recover by asking the user to provide a different string, for instance, or to provide his or her own fix, rather than doing some automatic fixing like this. Okay? So if you're using the thing interactively, recovery options are good, because you can go as far as possible in the parsing without just giving up. Okay. The whole point of this design, when it comes to flexibility, which I was mentioning earlier, is that in the TFM library, no decision with respect to the effect of non-compliance issues is ever made. The whole point of TFM is to be exhaustive in terms of the potential errors that can come up, provide as many, that's for robustness, provide as many recovery options as possible, that's for flexibility, but the library itself will never make a decision with respect to what to do when an error is encountered. Okay? So no decision, only options. Just for the fun of it, this is a complete graph of TFM's error ontology. The point of this is not to read and to understand the whole figure. The squares represent the potential non-compliance issues, so the 22 of those. The ellipses represent the recovery options that are available in the library, the ones that you could select interactively, for instance. But the whole point of this figure is just to convey the feeling that when you write a parser, even for a relatively simple format, being exhaustive in terms of catching errors can quickly become quite intricate. Okay, so developing a complete and exhaustive error ontology is not easy, and it becomes complex quite rapidly. All right. What does this have to do with validation of the TeX Live fonts? So there is a second library written on top of this one, which also very creatively is called TFM Validate, and which is a TFM validation library for TFM files. So the motivation of this second library, the development of which started less than 4 months ago, is actually curiosity for me rather than necessity. I never felt the need for validating thousands and thousands of font files, which for most of those I never use and probably never will. But I was curious as to the status of TFM compliance on a large batch of files. Okay, and so that was the first motivation, and the second one is also because writing given the existence of the TFM library, writing the TFM validate library was extremely easy to do. So I thought, okay, it's easy to do, it's going to be straightforward, it's going to take, I don't know, a couple of days, slightly more than that, but not much. So let's just do it and see what we get. And the key ingredient in that is a particularity of the Lisp language that I use, which is called the condition system. It's the Lisp infrastructure for handling exception. So what you would call exception handling in other languages, it's called signaling conditions and handling conditions in Lisp. So for those of you who know me, you know that I like to sneak in a bit of software engineering in my tech talks. So I'm just going to give you the idea of what makes the Lisp condition system quite peculiar and also extremely valuable tool for that kind of project. So if you've used a traditional programming language with exception management, you probably know about the usual try-catch statements, which are called with different names in other languages. Most of the time, there is a thing called try-catch, for instance, in Java. And the idea is this thing. So you have the call stack here, the func1 called func2 called func3, and you have a possibility to throw an exception, which non-locally will trigger something, maybe callback, something like that, signaling that there is a problem somewhere. If you throw an exception, it will go up the stack until it is caught by a try-catch statement, and that, if the exception is handled here, then the computation can resume from that point. Okay? If the handler here is not concerned with the exception, or if it declines to handle the exception, it can continue its voyage up the stack until it reaches another one, and finally, the try-catch statement, which is at the upper degree, will have the ability to catch the exception and resume computation for here. Okay, so this is a two-dimensional separation of concern, and in fact, it's wrong. Why is this design wrong? Because the try-catch statements in most programming languages out there do two different things at the same time, and there is no good reason for doing so. A try-catch statement is in charge of both catching an exception and restarting from there. Okay? These are two different things, and there is, from a software engineering point of view, no valid reason, no legitimate reason for doing both of these things at the same time and at the same place. A technical reason, which is not legitimate either for this, is because all these systems are usually implemented in terms of a facility which unwinds the stack when you go upward. So if you reach that point and the stack has been unwound, there is no way to restart from down below. And this is the reason why those statements are in charge of both catching exceptions and resuming computation from the same place. Okay? The common Lisp condition system does it right. It has a three-dimensional separation of concerns. In this system, you have the possibility to signal an exception, a condition, which is the same thing as throwing an exception. You have handlers that have the ability to catch conditions, but the big difference is that when a condition is sent up in the stack itself is not unwound. So it means that you can establish restart points at different places than where the exception was caught. And in that kind of scenario, what can happen, for instance, is that the exception, the condition is signaled, it goes up, it's caught by this handler, but this handler is not forced to restart from here, it could, but because there is also a restart point established down below, the handler, which is here, may decide to restart from here rather than from here. If the handler here declines to handle the exception, it will continue its travel up the stack, and this one will see both of these restarts as well. So in that system, you have a 3D separation of concerns. Catching an exception is different from signaling an exception, but it's also different from the position at which you want to resume the computation. Okay? It's a shame that the traditional programming languages do not do that, because it's not complicated to do. This system is also based on setJMP, longJMP, as most of the regular exception handling systems that exist. So it's really a pity that not more languages do things like that. There is a second point which makes the TFM validate library extremely simple to implement, but this one is not particularly specific to Lisp, is that Lisp is also an object-oriented system. And like, for instance, in Java again, if you do exception handling in an object-oriented programming language, then you can implement the exception handling mechanism in terms of object orientation. So, for instance, creating the ontology of errors boils down to create a hierarchy of condition or exception classes. And then when you signal a condition or when you throw an exception, what you actually do is just instantiate a class, and you end up with an object in the object-oriented sense. Okay, so it works also like that in Lisp. What does this have to do with the easiness to implement TFM validate? Well, as I mentioned before, the TFM library only provides options but never makes a decision. Okay, so it signals conditions and it provides recovery option. In technical terms, what does this mean? It means that the TFM library, which is down below, will have the ability to signal stuff, and recovery options are just restart points. But that's all. And the fact that the library does not make any decision simply means that there is no established handlers in the library. Okay? Why is this relevant for us? Because if you want to create a validation tool, what you want to do is catch all the potential non-compliance issues, but continue the parsing as long as possible in order to catch other exceptions. Okay? So the TFM library, which is up there, is in fact, it boils down to creating a big handler for all the TFM conditions. It catches everything, and then its only job is to use the restart, the available restart, which will allow me to go as far as possible in the parsing, to continue parsing as far as possible, instead of just giving up. But in order to do that, now you realize that there is no modification required to the TFM library. And that's because handlers may be elsewhere than restart points. And this is why this library was actually extremely easy to implement. Okay, I didn't have to touch the TFM library to implement that. Okay, so catch all conditions, select every time the softest restart, and then you have a validation tool. Okay. One more thing that I do is every time I validate a font, instead of just printing stuff on the terminal, for instance, I collect the conditions which are reified as first-class objects because it's object-oriented, and so all the function does. The function is called validate. It's here a validate font. The return value is the collection of all the conditions that were signaled, and then you're free to do whatever you want with that. Print them on a terminal, collect them into a list, or generate a website with that, for instance. Okay. If you add 10 more lines of code on top of this, you can easily validate a whole directory of fonts. Okay, it's simply a matter of calling the validation tool on every font in the directory and collecting all the conditions. Okay, and then after that, that's the point at which I thought, oh, that would be easy to apply this to the whole TeX distribution because there's a large bunch of fonts in there. Let's see what we get. Okay, and so maybe a couple hundred lines later, I have a tool which calls invalidate directory on the whole TechLive TFM directory of fonts and generates a website with the non-compliance reports printed, generated in a human-readable form. And so let's look at the results now. So as I was saying before, in the TechLive distribution, you have approximately slightly less than 80,000 TFM files. I'm currently skipping more or less 3,000 of those because these are actually not TFM fonts, but OFM or JFM, which I do not support yet. I hope it will be coming soon. And surprisingly, at least that was a surprise for me, I found slightly less than 800 fonts with non-compliance issues. Okay, so I started to investigate those, and fortunately for us, what I discovered is that even though this figure seems quite high, there is in fact only 4 non-compliance issues which I found. 3 of those can be considered not so important, so warnings only, and only 1 of those is a true error, something that makes a font completely unusable. The first warning that I get very often is the file overflow warning. So it means that the physical size of a TFM font is larger than the expected one. The TFM format declares its own size. And so what you get here is a file that is larger than expected. Okay? So this currently affects 628 files in the TechLive distribution. This is only a warning because the fonts seem functional. The second reason I chose to make this a warning is because TF2PL actually ignores the junk at the end of those files. Okay? Remember that this is black magic. It could very well have been the case that the declared file size would be wrong, okay? And in that case, I don't know what would have happened. But if you make the assumption that if there is a disagreement between the physical file size and the declared file size, then the declared one is right, you can hope for the best and continue parsing, okay? And it seems to be the case. The junk at the end of those files doesn't seem meaningful at all. I've looked at a couple of examples and I can't decipher what's going on in there. It's probably an artifact for some ancient files of padding to the next block on some, I don't know, some storage device or whatever. So it's not very clear what it is, but it doesn't seem to be really problematic. Second warning, sorry? Yeah, we'll get back to. I can answer that in the question and answer part because I've talked with Carl about this, and it doesn't seem to be, the situation is unlikely to improve. But more on this maybe later. Second warning: padded string overflow. So in the header of a TFM file, you have 2 so-called BCPL strings of a fixed length. So the strings also declare their length. There is one which is 40 bytes or 40 words, I don't remember, long, and another one which is 10 bytes or words long. But you do not need to use the full storage. So if you don't use the full storage, the trail of the string is supposed to be zeroed out. So what I call a string overflow is strings for which the declared used size is okay, but then instead of zeros at the end, you get something else, okay? So this is also a warning because it doesn't hurt. The strings are purely informational. There is 74 fonts affected by this, quote, problem, end quote. So you got an example of the error message which is printed here. This is also a warning because the origin of this problem is slightly obscure. I had a discussion with Doug McKenna about this. He thinks that the requirement to zero out the trail of a string was not there in the first place, but it was only added to PL2TF in version 1.3, which was probably 2 years after the initial release. But on the other hand, there is a paper from David Fuchs in a very early issue of the Tugboat, which claims that the string must be zeroed out, and it was prior to version 1.3 of TF2PL. So you don't really know. But the interesting thing is that this problem, there seems to be intentional abuse of the trail of the string. So for instance, many of the strings such as this one, contains something which is meaningful instead of zeros. For instance, here you see YNY Inc. So I believe that it gives you a very clear information about the origin of the font, okay? But it's not supposed to be here. So this is intentionally an abuse of the padding area behind the string, okay? So for that reason, I've decided to include the junk in the error message instead of just discarding it. Spurious char info, third and final warning that I got. This one is really is much more obscure. What I call a spurious char info is a character which is not supposed to be in the font, but still which is not completely zeroed out in the char info structure. Normally, in the TFM format, you have BC, which represents the minimum character code, EC, which represents the upmost character code, but you're not required that, it is not a requirement that all the characters in this range exist in the font, okay? So you can have holes in it. So if a character is non-existent, normally the char info structure is supposed to contain 0 indexes to all the tables. And there is no point in having something meaningful in this char info structure because the character does not exist in the font, okay? And it appears that in 66 fonts in the TeX distribution, there are non-existent characters for which the structure is not completely zeroed out, okay? And we don't really know why. Again, this is only a warning because if you look at TF to PL or PL to TF, PL to TF zeroes out the character in question, and TL to PF just ignores those characters. They are not printed in the output. So regarding the question before, regenerating from TL to PF to PF to TL and vice versa would remove the problem. Okay, so this is then considered not really an issue. The characters are not going to be used, so it can just be a warning. Okay. And finally, there is one serious error, and this is the only one. This is called the fixed word overflow in my library. Many numerical values in the TFM format are supposed to be within the range -16 + 16. All the character metrics are supposed to be within this range. So if you're not in this range, something is going really wrong because you would end up with characters, gigantic characters or something like that if you were to compute the actual width and height and depth and so on, okay? But the interesting thing is that only 2 fonts in the distribution are affected by that. This is RF Sans Bold, and there is another one which is also in the same directory. So those fonts are completely dysfunctional. The character metrics are completely messed up, and this one, for instance, you see that there is a repetition of 92 times this error. So probably it means that the width, heights, and depth tables are completely corrupted. And in fact, this is a serious problem because the font is unusable, and as a matter of fact, TeX will refuse to use those fonts, okay? It says that it says bad font metrics. So this is a true error. Okay, so this is the real conclusion this time. So to wrap this talk up, as I was saying before, my original motivation for doing this was curiosity rather than necessity, and also because it was easy to do, so it didn't take me a lot of time, so I thought, what the hell, just do it. Is it going to be useful or not, at the risk of putting the cart before the horse? We're not sure about that. Carl has expressed doubts about it. And again, to answer the question, he said to me that several times he attempted to put some pressure on TFM maintainers to fix their fonts, but he never succeeded. So will this contribute to that? I'm not sure. Maybe the greatest positive aspect of this work is not to put blame on ancient content, but maybe act as a vigilante for a future addition to TeX Live. Okay, so maybe the newer material is more likely to be watched over and fixed if there is a problem, rather than doing something on fonts that have existed for decades. You know, we don't know. The other merit of this work, also for me at least, is to answer my curiosity, and it gives you a general overview of the status of a large collection of TFM fonts, And it's interesting per se to discover that although a large number of fonts seem to be affected by non-compliance issue, there is in fact not much in terms of irrecoverable errors, only one, and this error only occurs in 2 fonts in the distribution, so this is probably good to know. Okay, perspectives of this, obviously adding OFM and JFM support, which is not, it will require modification to the original TFM library. I intend to do that soon-ish. So emphasis on ish. I would like also to check all the other font formats because I'm interested in writing parsers for the other font formats in order to bring those font metrics to the common Lisp world as well. I've already started to write a parser for OpenType. There is certainly a lot of room for improvement in the website itself, and mostly for the output of the thing and the way to access the cross-reference information and to make it even more accessible and even more human readable. And again, as a partial answer to the original question, the TFM library is currently only a parser, but it would not be complicated for me to write a font generator. And then one way to fix the fonts, if the maintainers refuse to do so, would be to load the file and then write it back with all the errors spotted and fixed for those errors which can actually be fixed. Okay? And that is all I have. Thank you very much.
Thank you, DJ. Are there any questions?
Would it also be possible to do the report on TeX Live in a continuous integration way?
That would be an interesting thing to do, yes. Currently it generates a website and the website is just updated daily with a cron tab entry. That's all. Probably Norbert could, I'm not sure if he's still listening to the conference, but Norbert, if you can hear me, please do some CI with that stuff. Thank you very much for the question. Thank you, Norbert, for the work.
Thank you for the great work, but the main problem I found with TFM files is that characters that are supposed to be there aren't there. And that cannot be caught with your method.
Yes, exactly. Yeah, you cannot detect that
there
kind of
is
problem.
one in a math font I remember in a family, a Polish family. That's very useful actually, and the character is completely missing. But we can do anything about that.
Yeah, no.
Any more questions before we can get some food?
Is there a chance to do it also for virtual fonts, for this VF? And
I'm sorry, come again?
Is there a chance to use the same tooling also for virtual fonts, for the VF and VPL files?
Not now, but that's an idea. Yeah, I'm all for it.
Just enhancing your list of things to do.
Yeah, it's an ever-growing to-do list.
Out of curiosity. Okay. Thank you very much.
All right, thanks.
Then we go for lunch.